Welcome to eMath. Today we are looking at functions in chapter 2, functions. So a function basically is a rule, usually denoted by letters like F, G, and H, a rule that assigns each element in a set X to at most one element in the set Y, right? It's a rule that assigns each X in X, it assigns that X to at most one Y in big Y. And it's usually denoted by F of X equals Y. That assignment is usually written as F of X equals Y. So in this rule, capital X is called the domain of the function. The set capital X is called the domain, while Y is called the range of the function. All right. So small x, which is an element of capital X, is called the independent variable or the input. Independent variable or the input, while small y, element of big Y, is called the dependent variable because it depends on X, dependent variable, or the output. Okay, so our main subject in this chapter 2 is going to be in 2.1, specifically is going to be finding domains and function values of given functions. Finding function values and domains of given functions. Okay, let's start with the function value. Function values and domains of given functions. So given, let's look at sample questions. Question 17, for instance. So given f of x equals 2x plus 1, all right? So that's the rule, okay? So for each x, x assigns each x, the function assigns each x in the domain a value y, which is equivalent to 2 times that x plus 1. That's what this simply means. Okay, so given that function, we are asked to find f of 0, f of 3, and f of -4. So these are called function values at specific x values, right? So f of 0 simply means find the value of the function when x equals 0. Find the value of f when x equals 3. Find the value of f when x equals -4, and so on. So when x equals 0, the function value at 0 will be 2 times 0 plus 1, all right? So this is my f of x, which is equal to this. So f of anything simply means replace x in your expression by that thing. So f of 0 is just replacing x with 0 and simplifying. So it will be 2 times 0, which is 0, plus 1, which is 1. So f of 1, or function value at x equals 0, is 1. Similarly, we can find f of 3, 2 times 3 plus 1, replacing x with 3 in your expression for the function. So it becomes 2 times 3, which is 6, plus 1, 7. F of -4 will be 2 times -4 plus 1, which is -8 plus 1, which is -7. All right. So that's how to find function values for given specific functions. Let's take another example. This is question 18, all right? This is 18 of problems 2.1, of course. Problems 2.1. So number 18 says, given that h of s, okay, h is the function, of course. I told you functions can be represented using letters, both capital and small letters, f, g, and h being the commonest of them. So h of s is given to us as 5s squared minus 3. And we are asked to find the following function values. H of 4, find h of square root of 2, and also find h of 2 over 3. Okay, so we do the same thing. If h of s is this guy, h of 4 simply means replace s with 4 in this expression for h of s. So it will be 5 times 4 squared minus 3, which is 5 times 16. So what's 16 by 5? Let's quickly get that. 5 times 16, which is 80, minus 3, which is 77. Similarly, h of square root of 2 is equal to 5 times square root of 2 squared minus 3, which is, we know that square root of 2 squared will just be 2 by our laws of exponents. So it's typically 5 times 2 minus 3, which is 10 minus 3, which is 7. And that's my function value at the point x equals 2. Then h of 2 over 3 will then be, replace s with 2 over 3 squared minus 3, which is 5 times 4 over 9 minus 3, which is 20 over 9 minus 3, basically. Okay, which is negative 7 over 9, if I'm not mistaken. Okay. Okay, so that's how to find function values, and you can go on and on and on and keep replacing x. Okay, let's look at number 23. Number 23 says, given that f of x is x squared plus 2x plus 1. Find f of 1, f of minus 1, and f of x plus h. Okay, find the function value at these points. So in this case, f of 1 will be the same thing. Replace every x in the expression with 1. So 1 squared plus 2 times 1 plus 1, which is 4. F of negative 1 squared plus 2 times negative 1 plus 1, which is 1. Negative 1 squared is 1 minus 2 plus 1, which is 0. Okay, and f of x plus h will be, replace every x in the expression with x plus h, basically. All right, so it becomes x plus h squared plus 2x plus h plus 1. Same story, okay? We can open up our brackets. We know that x plus h squared is the same as x plus h times itself. 2x plus h plus 1. Open up our brackets. We get x times x squared. X times h is xh plus another xh plus h squared. Open up this bracket, plus 2x plus 2h plus 1. Collect like terms. We get it to be equal to x squared plus 2xh plus h squared plus 2x plus 2h plus 1. So that's our answer there. That's our f of x plus h, basically. Okay, and so you can go on and on and on and find these function values at given x values or given points. Okay, let's look at finding domains. So the domain of a function basically is the set of x values for which the function is defined, all right? The set of x values for which f is defined is called. So the domain is the set of x values for which the function is defined or for which the function makes sense, all right? For which it makes sense. So when finding domains, we want to find those x values for which the function makes sense, for which there is no problem with the function, basically. All right. So we will encounter cases of domain where f of x is of the form sum a over x plus or minus a. All right, fractional functions where we will find the domain by looking at the set of values for which the denominator is not 0. All right, because looking at this fraction, the only thing that can go wrong here is when we are dividing by 0. So in order for this to be defined, our denominator cannot be 0. So if we can find all x values for which the denominator is equal to 0, all right, if we set denominator to 0 and solve for x, then our domain will be all x values except those x values for which the denominator basically is equal to 0. All right, that will then be how we do our domain. Okay, let's look at typical examples of domain type questions that we will encounter. So we are still on problems 2.1. We're still in problems 2.1. And I want us to look at question 5. Number 5 of 2.1. So number 5 says find the domain given f of x is equal to 6 over x minus 1. So I ask myself, remember that functions like polynomials, quadratic functions, and so on are defined everywhere on their domain, which is all real numbers. All right. We are working here in this module in the set of real numbers. Okay, so I'm looking at this. Which real number can make this fraction have a problem, can make this fraction not defined? All right. So if I substitute x equals 1, for instance, if I substitute 1 in place of x, 1 minus 1 will be 0 in the denominator, all right? And 6 divided by 0 will be undefined, okay? So that tells me that my domain is then all real numbers except 1. because 1 makes my denominator 0, which makes the entire fraction undefined. Okay, so in solving for the domain of this function, I ask myself, what can make this function not defined? It's only when the denominator is equal to 0. All right, then I solve this equation for x, and x will then be equal to 1. So the domain therefore is all real numbers, x, or in all real numbers such that x is different from 1. Or you can just also write it alternatively. You can just say x different from 1 is the domain of this function, right? You can just say x different from 1 is the domain, or you can write it as the set. So x different from 1 simply means x can be any real number except 1, because if x is 1, then we will be having division by 0, which is not possible in the set of real numbers. Okay, so that's therefore the domain of this function. So the main thing is just inquiring, asking yourself, what can make the function undefined or not exist or not make sense? All right, let's look at number 7. Number 7 says our f of x is equal to the square root of x minus 3. Okay, again, I'm asking myself, what will make this function not defined, basically, right? So this function will not make sense when we have a negative quantity in the square root sign. Remember that we can't find the square root of negative numbers in the real number space, all right? In the real number space, we can't find square roots of negative numbers. So this function will be undefined when x minus 3 is less than 0. Okay, when x minus 3 is less than 0, then our function here is going to be undefined. So basically, I should be saying that my function will only be defined, right? Will only be defined when x minus 3 is greater than 0 or equal to, because the square root of 0 is 0, can be found. So this thing will only be defined whenever everything in your root sign is bigger or equal to 0. Then we will be fine. And this will only happen when x is, you solve this linear inequality for x, all right? We just saw solving linear inequalities in our previous sections. So we solve this linear inequality for x and get x greater or equal to 3. Okay, so this is then the domain of our function. All real numbers greater or equal to 3. So notice that if you put a real number less than 3, for instance 2, in there, 2 minus 3 will be -1, whose square root cannot be found in the real number space. All right, so if you substitute any real number greater or equal to 3, then this square root will make sense. It will be defined. So this is therefore the domain of the function. You can also write it in interval notation as the interval 3 infinity, like that, as your domain. Okay, let's look at more examples. So it just depends on the type of function. If it's a radical function, then you are looking at its definition in terms of whether the square root or cube root can be found or not. Note that odd roots of negative numbers can actually be found. So if my f of x was cube root x minus 3, okay, and I was looking for the domain, then the domain of this function will be all real numbers, basically, all real numbers. Or we can write it in mathematical notation as x is an element of all real numbers like that. Okay, because whether you put in a negative number here or a positive number, its cube root can be found. All right, for instance, the cube root of -8 is -2, for instance. All right, so all odd roots of negative numbers can be found. Take note of this. So which means cube roots, fifth roots, seven roots, and so on can all be found, while all even roots of negative numbers cannot be found in the real number space. Okay, take note of this. Okay, let's continue with more examples. This example is number 11. Number 11 says that our f of x equals, we are finding domains, 9x minus 9 divided by 2x plus 7. So this is clearly a rational function, all right? So when will the numerator be not defined? So looking at the numerator, it's a linear expression which will always be defined, meaning that if you substitute any real number in the numerator, you don't have any problems. All right, now let's look at the denominator. Now it's possible for the denominator to be 0 at some point for some value of x. All right, so for this entire fraction to be defined, we need to have that the denominator must never be equal to 0. For it to be defined, f is defined when 2x plus 7 is not equal to 0. All right, so then we find out when is 2x plus 7 equal to 0, so that our domain will be all x values except those values that make 2x plus 7 equal to 0. Okay, so when is it equal to 0? We solve for x in this linear equation. 2x is equal to -7 and x is -7 over 2. So this is when 2x plus 7 equals 0. That happens when x is -7 over 2. So therefore, our domain is all real numbers except -7 over 2. X can be any real number, but x cannot be -7 over 2, because whenever x is -7 over 2, our denominator will be 0, which will make division by 0 not possible. All right, so domain is all x values for which your function is basically defined. Okay, let's take another example. So you'll be looking at both numerator and denominator, because sometimes we have the cases where the denominators are also an issue. Okay, look at number 15. 15 says, given 3 minus x squared divided by 3x squared minus 5x minus 2. Okay, we are looking for the domain of this function. Now, the numerator is a quadratic. Okay, if you substitute any real number here, you don't have any problem. Okay, so in general, take note that in general, polynomials, okay, of the form, polynomials are functions of the form ax to the n plus bx to the n minus 1 plus blah, 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 plus cx plus d, okay, of this form. So quadratics are typical examples: ax squared plus bx plus c, or ax cubed plus bx squared plus cx plus d. Okay, these type of functions are typically, their domain is all real numbers. Okay, their domain is all real numbers, which means they are defined everywhere, which means there is no real number which when you substitute into them, you will have a problem. Okay, so our numerator here is typically this form, so it is defined everywhere, we don't have any problem. Our denominator is also that form, but if whatever our denominator is 0, then the entire fraction will give us some problems. It will be undefined, right? Whenever this denominator is 0, then this divided by 0 will be undefined. So when is this denominator 0? We can only find that out by setting this denominator to 0 and solving for x. Set your denominator to 0, solve for x, then your domain is all real numbers except those x values you solved for. All right, so we solve this quadratic. Let's factor it using our trial and error method of factoring that we saw in our previous sections. So factors of 3x squared are 3x and x. Factors of minus 2 are 1 and minus 1 and 2, or 1 and minus 2, all right? 1 and minus 2. And factors are 1 and minus 2, 1. Okay, so that's set. If we cross multiply and add, we get 3 times minus 2 is minus 6 plus 1, which is minus 5x. Minus 6x plus x, which is minus 5x, which is our middle term. So that tells us by trial and error method that these are our factors, basically. So then, our factors are 3x plus 1 times x minus 2 equals 0. Okay, and then we are ready to solve for x. So from 3x plus 1 is 0, or x minus 2 is 0. 3x is negative 1, x is minus 1 over 3, or x is 2. Okay, so our domain will be the set of all x is in all real numbers, but x is not negative 1/3 and x is not 2. Okay, because whenever x takes any of these values, our entire expression here will be equal to 0. Okay, which is not what we want. So that's then the domain of that function. Okay, let's look at another example, number 8. Number 8 says, number 8, f of z equals 1 over square root of z minus 1. Okay, so in this example now, f of z equals 1 over this. So I'm asking myself, when will this guy be undefined? What can go wrong in this function? So the only thing that can go wrong is when the denominator is 0, or when what is inside our square root sign is negative. Okay, so this, what is inside the square root sign, that's z minus 1, must be strictly bigger than 0. Notice that. Okay, because if it's equal to 0, it won't have problem with the root sign, but it will have problem with being in the denominator. We can't have a 0 in the denominator. All right, so it must be strictly bigger than 0 for this function to be defined. So solving this inequality, z is bigger than 1, and that's our domain, that's set there, that which can also be written as 1 round brackets, which can also be written as round brackets 1, infinity, basically. Okay, so that's that about domains. Let's take one more example. So look at question 16. 16 says our f of r is equal to 2 over r squared plus 1. Okay, and we have to look for the domain of this function. Now, looking at this function, what can go wrong? Look at the denominator. Now, common thing that you quickly say is that if the denominator is 0, then we will have a problem. But look critically at the denominator, you will see that it can never be 0. All right? Because if you substitute any real number here and square it, it's going to be positive always. Any positive number plus 1 is already bigger than 0. Okay, so our denominator can never be 0. So the domain of this function would then just be all real numbers. Okay, this function will just be defined for any real number that you substitute into it. It will be defined for any real number that you substitute into it. It will be defined basically. Okay, so that's that about domains. We will see more of this in your lectures in class.